This is the review for the first semester final for Millard West High School Chemistry. Okay, the first 6 problems you were trying to identify if the following were physical or chemical changes. If you look at the first one, iron metal is melted. That's simply a change in state. Any changes in state are physical changes. Wood burning in air. Okay, this is combustion reaction. You have new products formed. Can't easily be undone. This is definitely a chemical change. Iron combining with oxygen to form rust. Once again, new products are formed. That's chemical. A rock is broken into smaller pieces. Anytime you have like crushing, tearing, that's physical. It's still a rock, it's just in a little different form, smaller pieces. Milk turning sour, that is a chemical change. You have new substances forming. Steam from your hot shower condenses onto a cold mirror. Once again, any phase change or change in state is a physical change. In this exercise, we're going to write some numbers in scientific notation. Okay, the first number, 238,000. Okay, you have to remember for scientific notation, it can only have one number in front of the decimal, and it can't be a 0, so it's got to be between 1 and 9. So the decimal is understood to be here. We're going to move it to the left, 1, 2, 3, 4, 5, which is going to make this number 2.38 times 10 to the 5th. Okay, for number 8, same thing. We're going to move the decimal to the left, 1, 2, 3, 4, 5, 6. So as you move the decimal to the left, the power gets bigger. This one is 1.5 times 10 to the 6th. On number 9, we have a number smaller than 1, and so we're going to move the decimal to the right, 1, 2, 3, 4. So this is going to be 1.67 times 10 to the negative 4th. Finally, for number 10, we're going to move the decimal to the left, the right, 3, 4, 5, 6, 7. Well, this one's going to be 7.2 times 10, the power gets smaller, to the negative 7th. A common unit for expressing volume in chemistry would be the liter. You can use prefixes in front of that like a milliliter. Another common unit for expressing volume would be something like a cubic centimeter, cubic meter, something like that. What piece of lab equipment would be the most precise for measuring volume? You know, if you're given a list, you basically want to look for the one that has the smallest unit markings on it, the smallest graduates. So, for example, like a graduated cylinder would be more accurate than a beaker, but something like a burette or a pipette would be more accurate than a graduated cylinder. So it just depends on what ones you're given. Things that are evidence of a chemical change, you're going to have like a dramatic color change. You may also, if it's in liquid, you may see bubbles form, which is basically a gas being evolved. Other things you may sense, it may give off some odor, kind of related to the others. You may have heat or light emitted. You may also have formation of a precipitate. And as you recall, a precipitate is a solid that forms out of a liquid solution and generally will, it'll give it either a cloudy appearance or you'll see a solid that falls to the bottom. Okay, the differences between hetero and homogeneous. Heterogeneous looks different. You can see the different parts. Whereas homogeneous looks the same. A common name for a homogeneous mixture, sometimes they're referred to as solutions. So heterogeneous looks different, homogeneous looks the same. How can each of the following be separated? A compound must be separated by chemical means. The reason you have elements that are chemically combined, they are bound together, sharing or gaining and losing electrons, stuck together by opposite electrostatic charges, but you need some kind of chemical means to separate them. A solution, because a solution is simply a homogeneous mixture, you can separate a solution through physical processes. An example, if you had like a saltwater solution, you could separate the salt and water by boiling. So a physical change, a change in state like boiling, could separate them. And then a mixture would be another physical separation. Think of an example. Say you had a mixture of like nuts and bolts in a pail. You can physically sort them. You can pick them up with your fingers and put them in two different piles. Sorting, sifting, those sort of things are physical separations. Who better to tell you about their scientific theories than the scientists themselves?
Hi, I'm Niels Bohr. I'm known for my planetary model of the atom. I am Dmitri Mendeleev. I am the creator of the periodic table of the elements.
I'm Ernest Rutherford. My famous gold foil experiment helped discover the nucleus of the atom, that it contained almost all the mass of the atom, and it had a positive charge.
The three subatomic particles are the proton, neutron, and electron. Their masses in AMU, which stands for atomic mass unit. Protons and neutrons essentially have a mass of 1, whereas the electron is the mass of 1/2000th of an AMU. The relative charge, protons are positive, neutrons are neutral, thus they have no charge. Electrons have a charge of -1. As far as where they're located, the protons and neutrons are located within the nucleus of the atom, whereas the electrons exist in orbitals surrounding the nucleus. The main distinguishing feature that makes all atoms of one element different from atoms of another is the number of protons within the nucleus. The mass number is simply the number of protons plus the number of neutrons. How do you calculate the number of neutrons in an atom? What you will do is you will take the mass of that particular isotope and you will subtract from it the number of protons, which is the atomic number. So the mass number minus the atomic number will give you the number of neutrons. How do you calculate the number of electrons? Electrons will, in a neutral atom, will be the same as the atomic number, the number of protons, so the positive and negative charges cancel out. If you have a cation, which is a positive ion, there will be more protons than electrons. And if you have an anion, which is a negative ion, you will have more electrons than protons. And then finally, E, how do isotopes of a given element differ from one another? They're going to differ by atomic mass. So they have different numbers of neutrons. How are they the same? They have the same number of protons because they are the same element. The proton number, the atomic number, is what defines what an element is. An atomic mass unit is defined as 1/12 the mass of a carbon-12 atom. Okay, bear with me on this diagram. It may be a little hard to write in all these boxes, but we'll give it a try. Okay, so the first one, we know that this is silver 108, because that's the symbol for silver. 108 is the mass. It's written as a superscript to the left side. We know the atomic number of silver is 47, and it's listed there as a subscript to the left side. The mass is 108. So we know the atomic number and the number of protons are the same, 47. Okay, to find the number of neutrons, protons plus neutrons will be the mass. So if I take 108 minus 47, should be 61. And the number of electrons, because there is no charge, will be equal to the number of protons. It should also be 47. The next one, we have nickel 59. So that indicates the particular isotope. Atomic number is 28. The mass is 59. The number of protons is 28, same as the atomic number. So what number plus 28 is 59? Should be 31 is the neutron number. And once again, the electrons will be 28. Okay, carbon 12. This time we have to write the symbol. So I would write carbon here, 12 is a superscript, and 6 is a subscript. So mass of 12, atomic number 6, because it's carbon. So atomic number is 6, mass is 12, number of protons is 6, number of neutrons would also be 6, the electrons would be 6, because there is no indication that that is an ion. Okay, this next one, you have an aluminum. This is actually aluminum 27, that is a 3+ ion. So, aluminum, let's see if we can get it in there. That's supposed to be an M. Okay, so the atomic number is 13, mass 27, number of protons will be 13, the number of neutrons will be 14, 14 and 13 is 27. Notice it has a 3+ charge, which means I need 3 more protons than electrons. I only have 10 electrons. Okay, we have an oxygen 16 ion with a 2- charge. So let's see, oxygen 16. Okay, so the atomic number is 8. Mass is 16. Number of protons is 8. It has 8 neutrons. And because we have a net charge of 2 negative, that means I have 2 more electrons than protons. It also has 10. For this last one, we know that it has an atomic number of 20. So the symbol, I'm just going to write it down here, 20. And then notice there are 20 neutrons, so then it has a total mass of 40. What element has 20 protons? It's calcium. And then looking at the number of electrons, there are 2 less electrons than protons, therefore it has a 2+ charge. This is a calcium cation. So let's see, this is calcium 40. The atomic number is 20, mass